Hello friends, in this tutorial we'll see how to delete a node from a linked list. So in the first case, if we are asked to delete a node which is the first node of the linked list or which is the head node of the linked list, so in that case what we'll do is we'll simply take a pointer to the which will point to the head node. Let me call this pointer a Q pointer, right? Then I'll simply, as I'm going to delete this node, this will be no more my head node, so I'll simply move my head node to this node by saying head equal to head arrow next. So I'll bring my head pointer here. I'll move my head pointer. I'll not move head node, but I'll move my head pointer, right? Head pointer which was pointing to the first node of the linked list, or head node of the linked list, will point to this node because this will be deleted, right? So once I bring my head node, I'll simply say free the node or free the memory pointed by Q pointer, right? So the code is very simple, like this. I'll say head equal, first I'll say Q equal to head, then head equal to head arrow next, right? So because of this, head pointer will go from here to here because head next is pointing here, so head will point here. And then I'll say free Q, right? Free the memory pointed by pointer Q. So this, because of this, the head pointer already has moved from here to here, head, and because of this the memory will be released. Now thus the first node gets deleted. Now let's say in other case, if I'm asked to delete some node which is in the middle or on the position other than first, or let's say other than first position, right? So let's say how to delete that node. Again, let's say this is our linked list, case 2. We are asked to delete the node which is not the first node. So how will we delete that? So again, this is the head node. These are the positions of the node. And let's say we are asked to delete the node which is on fourth position. Right. So in this case, what will I do is I'll have one pointer which will be pointing to the node which we want to delete. Let me call it as a pointer P, and one pointer which will be pointing to the node previous to this node, right? So that is Q. So I'll need these two pointers. Now once I have these two pointers, so the first pointer will be pointing the node which I want to delete, right? And the other pointer will be pointing to the node which is previous to this node to be deleted, that is here on third position, Q. So what I'll simply do is I'll simply say the next pointer of Q will point to this node, and this node is being pointed by P arrow next. So I'll simply say Q arrow next is equal to P arrow next, so that I'll break this link and I'll have link between these two nodes, right? So now I don't have link between these two nodes, so I have this link, and now I'll simply say free P, right? So as simple as that. So the problem is how to get these two pointers here, right? So I'll simply start from this node, because I have address of this node. I'll take Q here, right? Then I'll say for I assigns to 2 to L minus 1, that is position of insertion minus 1, say Q equal to Q next. So that will get a Q here, and then I'll simply say P equal to Q next. So I'll have P here. Then I'll write the code for deletion by saying Q next equal to P next and free P, right? So it's like this. So head Q equal to head, initialize Q to this, right? Then say I equal to 2, because we want to take our Q from 2 to position of insertion, position of deletion minus 1, right? So that's why I initialized I to 2, while I is less than equal to L minus 1. I want to take my head pointer from 2 to position of insertion minus 1, that is L minus 1. That's why I said while I is less than equal to L minus 1, simply say Q equal to Q arrow next, right? So and I plus plus, right? So this simple while loop will take Q from here to the position of insertion minus 1. So once I have our Q there, you take P equal to Q next, right? So once we have pointers in place, we'll simply write, we'll simply say Q next equal to P next, right? So I'll write the code here, Q next equal to P next. Because of this link will be created. Q next, which was earlier pointing here, now it will point where P next is pointing. P next is pointing here, so Q next will point here. And then I'll simply say free P. Okay, that's the very simple code for deleting a node. This code will also take care of deleting the last node of this linked list, right? So this will take care of deleting the first node. This will take care of deleting the last node of the linked list, right? Okay, so let's write a complete function to delete the node from a specific position. So here is our function delete. So this function will return the address of the first node of the linked list after deletion, because the first node may get modified, as in this case when you delete the first node of the linked list, the first node or head node changes from this node to this node. That's why it's important to return the address of the first node of the linked list. So the return type of this insert function will be a pointer or address of the structure node. So structure node address, that's the return type of this function. Then name of the function delete. To this delete function, we need to pass the address of the first node of the linked list. So we need to have a pointer. Let me take this pointer, struct node star head. Also we need to tell the position of deletion, int L. Now let's take two pointers I'll be needing. One is P and Q, right? So let's declare them. Struct node star P and star Q, both are structure node pointers because they will point to structure node type data. Now initialize Q to the head node, right? So initialize, or before initializing this Q, let's check the position of deletion. So we'll check the position of deletion. If L equal to 1, that means if the position of deletion is 1, what we'll simply do is we'll take Q equal to head, right? So we'll take our Q to head, we'll point Q where head is pointing, and then we'll simply say head equal to head arrow next. So as we are going to delete this node, we should bring our head from here to here, right? So and then we'll simply say free Q, because Q is pointing to this node, so free Q. And after freeing Q, we should simply return the address of the modified linked list first node. So modified linked list first node is address is in head pointer, so we should return that head. Return head. Okay. So this code takes care of deletion of first node. But if the node to be deleted is not first node, then we should write the code which we discuss here, right? So in that case, what we need to do is we need to again start our Q here, right? So Q equal to head, right? Then we need to start taking our head from 2 to L minus 1, 2 to L minus 1. So I should say I equal to 2. This is just a counter which will help me to take my Q from node number 2 to L minus 1. I'm not taking I equal to 1 to position of deletion minus 1 because I have already taken my head at location number 1, right? So I need to go from 2 to L minus 1. So that's why I have initialized this I to 2. Now while this I is less than equal to L minus 1 position of insertion, sorry, position of deletion minus 1, I will say Q equal to Q arrow next, right, and I plus plus, right? So this while loop, let's see whether it works or not, right? So I equal to 2 and L is 4, so L minus 1 will be 3, right? So 2 is less than 3, so condition true, take Q from take Q to next, right? So Q is here, so Q next is here, so our Q will be here, right? So here is our Q. Now increment I becomes 2, so 2 is less than 3, condition is true, so execute the while loop in while loop. It says take Q to Q next, so Q is pointing here and Q next is pointing here, so Q will point here, right? Increment I becomes 3 this time. So now 3 is not sorry, this condition has to be less than L minus 1, has to be less than L minus 1, okay. So now I has become 3, so 3 is not less than 3, right? So condition becomes false, so our Q will stop here only, right? So and we wanted our Q here, right? So now okay, so I think we made a mistake here. So let me go over it one more time. So I is 2 and our Q is here, let's say our Q is here, so I is 2, so condition is true because 2 is less than 3, so 2 is less than 3, condition is true, so our Q will go from here to here, right? Okay, our Q will go from here to here, right? So okay, so let me clear this mess first. I think it has to be less than equal to L minus 1. So our Q is here, Q is pointing where head is pointing, right? And we want to go from 2 to L minus 1. L minus 1 is 3 in this case, right? So I is 2 and L minus 1 is 3, so 2 is less than 3, so condition true, take Q from here to Q next, so Q is here now. Now increment I becomes 3, right? So 3 is equal to 3, right? 3 is equal to 3, so condition is still true, take Q from here to here, right? Okay, so we got our Q at this position, right, where we wanted. So it's this loop simply says take your Q from 2 to L minus 1. So that loop helps us to take our Q to L minus 1, right? Now once we are at L minus 1, take a pointer P which will point to Q next. Q next is pointing here, Q next is pointing here, so P will point here, right? So I'll say P equal to Q next, right? Then I'll simply say Q next equal to P next, so Q next is pointing here, so P next will point q next equal to p next is pointing here, so q next will point here. So q next will point where p next is pointing, right? So this will create this link, right? And then you simply say free p, and then we have to return the address of the modified linked list in this case also. So address of the first node or head node is there inside head pointer. So that's it. Again, this code does not take care if the position of insertion is position of deletion is more than or greater than 5. For example, there are 5 nodes in the linked list and we are asked to delete the 10th node, so that is not taken care by this node, by this code, right? Okay, thank you for watching. Stay tuned to watch other videos on other chapters like doubly linked list, circular linked list, and other algorithm related chapters or topics. Okay, thanks again.